For eons, humanity has gazed upon the cosmos, often with a sense of wonder and detachment. We perceive the sun as our stable, life-giving star, a constant in the vast cosmic ocean. Yet the universe is a dynamic and often violent place, far beyond our everyday comprehension. The potential for Earth's demise is dramatically amplified by the terrifying prospect of massive celestial objects colliding with our sun. Such an event would not merely disrupt our solar system, it would unleash forces beyond imagination. These scenarios paint a grim picture of Earth's ultimate fate, a future where our world is irrevocably altered or utterly destroyed. The scale of destruction directly correlates with the mass of the impacting object. From rogue planets to wandering black holes, each potential collision presents a unique and horrifying pathway to oblivion. In every one of these catastrophic scenarios, Earth faces an inescapable annihilation. Our very existence hangs precariously in the balance, subject to the whims of cosmic mechanics. We must confront the chilling reality that our sun, the source of all life, could also be the catalyst for our end. Imagine a rogue planet, perhaps a gas giant several times the mass of Jupiter, hurtling through interstellar space. If its trajectory were to intersect with our sun, the consequences would be immediate and cataclysmic. The sheer kinetic energy of such an impact would be unfathomable. This collision would trigger a colossal coronal mass ejection, or CME, of unprecedented scale. The sun's outer atmosphere, the corona, would erupt with an explosive force that dwarfs any solar flare ever observed. This devastating CME would be directed outward, a superheated wave of plasma and magnetic fields. Satellites orbiting Earth would be instantly fried, their delicate electronics overwhelmed by the intense radiation and electromagnetic pulse. Communication networks would collapse globally, plunging humanity into an immediate, terrifying darkness. Earth's power grids would be disrupted on a scale never before conceived. The sudden surge of energy would overload transformers and power lines, leading to widespread blackouts that could last for years. The immediate effects on Earth would be catastrophic, plunging civilization into chaos and technological collapse. But the direct impact is only the beginning. Beyond the immediate devastation, there are profound indirect risks to Earth. The sun's internal structure would be violently disturbed, potentially leading to prolonged periods of instability. This could manifest as an increase in solar flare activity or a permanent alteration of the sun's energy output. Such an event would fundamentally change the delicate balance that sustains life on our planet. The very light and warmth we depend on could become erratic, leading to unpredictable and extreme climate shifts. Our world would be irrevocably scarred, if not entirely consumed. Consider a different cosmic intruder, a brown dwarf. These celestial objects are often called failed stars because they are too massive to be planets, but not massive enough to ignite sustained nuclear fusion like our sun. A brown dwarf, perhaps dozens of times the mass of Jupiter, could enter our solar system. If a brown dwarf were to collide with the sun, the impact would be less about a sudden explosion and more about a profound long-term disruption. The sun's internal dynamics would be violently perturbed, leading to a dramatic increase in solar flare activity. These flares would be far more powerful and frequent than anything we currently experience. The resulting CMEs would pose an exceptionally high risk to Earth. Our planet would be bombarded by waves of energetic particles and radiation, stripping away our atmosphere over time. The very fabric of our protective magnetosphere would be strained to its breaking point. Beyond the direct solar effects, the gravitational influence of a brown dwarf collision would be immense. Planetary orbits, including Earth's, could be significantly destabilized. Our world might be flung into a highly elliptical path, or even ejected from the solar system entirely. Such orbital changes would drastically alter Earth's climate, rendering it unrecognizable. A closer orbit would lead to runaway greenhouse effects, boiling away our oceans. A more distant orbit would plunge us into an eternal ice age, freezing all life. Either scenario spells the end of our world as we know it. Now contemplate a truly apocalyptic scenario: the Sun merging with another low-mass star, such as a red dwarf. These stars are far more common than Sun-like stars, and while smaller, they still possess immense gravitational power. A direct collision would be a catastrophic merger of two stellar bodies. The immediate aftermath would be a hypergiant flare, an event of unimaginable energy release. This flare would outshine the Sun for hours, perhaps even days, bathing the inner solar system in a blinding, lethal light. The sheer intensity of this radiation would be beyond anything life could endure. The inner planets, including Mercury, Venus, and Earth, would be vaporized almost instantaneously. The intense radiation from the merger would strip away their atmospheres and melt their surfaces. Our world would become a superheated cloud of plasma and dust, indistinguishable from the stellar inferno. Vaporization would occur not only from the intense radiation, but also from the gravitational chaos unleashed by the merger. The tidal forces generated by two stars combining would rip apart anything in their immediate vicinity. Earth would be torn asunder, its very atoms scattered into the void. This is not merely a disruption, it is the total annihilation of Earth. Our planet would cease to exist, absorbed into the newly formed, more massive star. The remnants of our world would become part of a new stellar entity, a silent testament to a cosmic collision of unimaginable power. The most terrifying cosmic encounters involve black holes, objects of such immense gravity that nothing, not even light, can escape their grasp. Their presence alone can warp space-time, and their direct interaction with our Sun would spell an end unlike any other. Consider first a primordial black hole. These hypothetical objects are thought to have formed in the early universe, some potentially being no larger than an atom, but possessing the mass of a mountain. If such a tiny black hole were to pass through our solar system, its impact would be minimal. It would likely pass through the Sun or Earth with little more than a ripple, its small size making a direct, destructive hit statistically near impossible. While fascinating, a primordial black hole poses no significant threat to Earth's existence. The true danger emerges with a stellar mass black hole, the remnant of a collapsed massive star. These objects can be many times the mass of our Sun, yet incredibly compact. Their gravitational pull is immense, capable of tearing apart stars. If a stellar mass black hole were to collide head-on with our Sun, the outcome would be swift and absolute. The Sun would be shredded, its material pulled apart by the black hole's overwhelming gravity. Our star would be consumed, leaving behind a cold, dark void where it once shone. Without the Sun's warmth, Earth would rapidly freeze, becoming a desolate, ice-bound rock. But the horror would not end there. As the Sun's material spiraled into the black hole, it would form an accretion disk, emitting deadly radiation. This runaway accretion would sterilize the solar system, ensuring no life could ever return. Even a grazing encounter, a near miss with a stellar mass black hole, would be catastrophic. The black hole's immense gravity would violently perturb the Sun, triggering massive solar flares of unprecedented power. These flares would impact Earth with devastating force, stripping away our atmosphere. Earth itself could be flung into a wildly disrupted orbit, perhaps ejected from the solar system entirely. Our world would become a rogue planet, drifting through the cold, dark interstellar void, its surface frozen solid. The lethal radiation from the Sun's violent convulsions would sterilize the planet, eradicating all life. The solar storms unleashed by such an event would be so intense that they would scour the surface of Earth, leaving behind a barren, lifeless husk. Our world would be rendered utterly uninhabitable, a silent monument to a cosmic near miss. The ultimate cosmic horror involves an intermediate or supermassive black hole. These behemoths, found at the centers of galaxies, possess masses ranging from thousands to billions of times that of our Sun. Their gravitational fields are so profound they can warp entire galaxies. If our solar system were to encounter such an object, the Sun would be spaghettified. This chilling term describes the process where an object is stretched and torn apart by extreme tidal forces, elongated into a long, thin strand of plasma. Our star would be ripped into ribbons, its material spiraling into the black hole. Earth would be vaporized by the intense radiation emitted from the Sun's spaghettification. The sheer energy released as our star is consumed would be an instantaneous, blinding flash. Our world would not even have time to freeze or be flung into space. The instant vaporization of Earth would occur before the black hole's tidal forces could even reach it directly. The overwhelming energy from the Sun's demise would be more than enough to obliterate our planet in a single terrifying moment. Our existence would end in a flash of light, absorbed into the cosmic abyss.